Good day everyone. Me and my groups are assigned to discuss about Trace 700 and Trace 3D software application. So first of all, let's define Trace 700 software. So it stated there is a legacy building simulation software from Train used for calculating HVAC loads and simulating buildings energy performance over a year. It's a Windows based program that doesn't offer a visual 3D building representation, focusing instead on two-dimensional data input. The software allows to customization of equipments, materials, and schedules, and can be used in both the design and analysis phases of a project. It's currently being phases out by Train in favor of Trace 3D Plus. So in Trace 3D Plus software, 3D Plus is Train's current generation's building design and analysis software. It's significant upgrade from Trace 700, offering a more intuitive interface, 3D modeling capabilities, and faster simulation speeds through cloud functionality. Key features include 3D modeling, cloud based simulations, comprehensive analysis, and integration with other tools. The historical development of trace software and its impact on the HVAC industry. How did Trace 700 and Trace 3D Plus shape the field of building energy model? Trace Trace software, initially launched in 1972, has significantly evolved along advancement in building energy modeling. The widely used Trace 700 established itself as an industry standard for HVAC design and analysis for over 2 decades. Although its 2D limitation hampered visual representation, the current Trace 300 Plus integrating Energy Plus and 3D visualization with BIM capabilities reflects a shift towards more initiative and integrate workflows in the industry. Trace software by Train has significantly advanced HVAC system design and energy modeling. Trace 700 released in early 2000s became widely used for its detailed load analysis and energy simulation based on the DOE2 engine, supporting sustainable building practices and LEED certification. In 2016, Trace 3D software or Trace 3D Plus replaced it with a modern 3D interface, faster simulation, and Energy Plus based modeling, enhancing accuracy and integration with BIM tools. Together with tools improve system efficiency, supported green buildings designs, and become essential in both industry and education.
Next is the advantages of using tree software in sustainable building design. How does it contribute to energy efficiency, environmental impact reduction, and compliance with green building standards? So the tree software supports sustainable building design by improving energy efficiency, minimizing environmental impact, and facilitating compliance with recognized green standards. In addition, it improves energy efficiency by accurately modeling how a building uses energy, allowing engineers to select high-performing systems, optimize their operation, and validate design choices that reduce consumption while maintaining the occupant comfort and performance goals. So, tree software helps create eco-friendly buildings by saving energy, reducing harm to the environment, and meeting green building rules. It also improves the energy use by modeling the building's needs, helping engineers choose efficient systems that save energy while keeping the building comfortable. So in conclusion, the tree software helps design sustainable, energy efficient buildings that reduce environmental impact to ensure comfort while meeting the green building standards. The primary applications of Trace 700 and Trace 3D Plus in HVAC design and energy modeling, and how do they differ in their approach to system simulation? So Trace 700 is a traditional DOE2 based software focused on 2D zone based load calculations and lifecycle cost analysis. It is widely used for retrofit projects and straightforward system comparisons. Trace 3D Plus uses the Energy Plus engine and the 3D BIM integrated interface, offering more detailed energy modeling, faster cloud-based simulations, and a better visualization for lead and ASHRAE compliance. So in short, the Trace 700 simplifies the system for faster modeling, while the Trace 3D Plus simulates them more uh, with the detail for higher accuracy and design flexibility. So next is the advantages of using Trace software in sustainable building design. How does it contribute to energy efficiency, environmental impact, reduction, and compliance with green building standards? So the Trace software supports sustainable building design by improving energy efficiency, minimizing the environmental impact, and facilitating compliance with recognized green building standards. In addition, it improves the energy efficiency by accurately modeling how a building uses energy, allowing engineers to select high-performance systems, optimize their operation, and validate design choices that reduce consumption while maintaining occupant comfort and performance goals. So the Trace software helps create eco-friendly buildings by saving energy, reducing harm to the environment, and meeting the green building goals. It improves energy use by modeling a building's needs, helping engineers to choose the efficient systems that save energy while keeping the building comfortable. So in conclusion, Trace software helps design sustainable, energy efficient buildings that reduce environmental impact and ensure the comfort while meeting the green building standards.
So, discuss the challenges and limitations of Trace 700 and Trace 3D Plus, and how might these issues impact the effectiveness of energy modeling in modern building projects. Trace 700, while historically reliable, lacks the advanced graphical interface and integration capabilities found in your tools. Its outdated engine limits the support for complex geometries and current energy codes, and Trace 3D Plus, though more modern, can have a steeper learning curve and hardware requirements. These limitations may reduce modeling accuracy, slow workflows, and hinder collaboration, ultimately affecting project efficiency and sustainable outcomes in modern, fast-paced building environment that demand high fidelity and integrated solutions. Discuss the Trace 3D Plus enhanced HVAC modeling and design through its 3D capabilities and BIM integration. And why is this important in the context of modern building workflows? Trace 3D Plus significantly enhances HVAC modeling through its 3D visual interface and seamless integration with BIM platforms. This allows designers to interact directly with building geometry, improving spatial accuracy and energy simulations. BIMI, BIM integration streamlines data flow between disciplines, reducing errors and rework. In modern workflows, that emphasize collaboration, efficiency, and sustainability. And this capability supports better informed design decisions and energy compliance and life cycle cost optimization, making it an essential tool for contemporary HVAC system planning and execution. Discuss compare the use of trace software with other energy modeling tools like Energy Plus and IESV. What are the strengths and weaknesses of Trace in comparison to these alternatives? Trace, Energy Plus, and IESVE are leading energy modeling tools, each with, with distinct strengths suited to different project needs. Trace, particularly Trace 3D Plus, is favored by HVAC engineers for its user-friendly interface, strong economic analysis capabilities, and seamless integration with train equipment. Though it lacks flexibility and advanced building physics modeling compared to its peers. Energy Plus, developed by the US Department of Energy, is a powerful open source tool offering detailed, accurate simulations of building systems. But it has a steep learning curve and limited economic analysis features, and ISVE provides a comprehensive platform for whole building performance analysis, including energy, lighting, airflow, and sustainability metrics. With strong compliance tools and visualization capabilities. However, it is costly and complex for beginners. In summary, Trace excels in HVAC and cost modeling, Energy Plus in detailed energy simulations, and ISVE in integrated environmental design and compliance. Discuss. In what ways does life cycle cost analysis, or LCCA, in Trace software benefit stakeholders? And how does it influence the financial viability of HVAC system choices? Life cycle cost analysis, or LCCA, in Trace software provides significant benefits to stakeholders by enabling informed, financially sound decision making for HVAC system selection. It evaluates the total cost of ownership over a system's lifespan, including capital investment, energy consumption, maintenance, and operational costs, rather than just initial purchase price. This comprehensive view helps building owners, engineers, and financial decision makers identify systems that offer long term savings and better ROI, even if they have higher upfront costs. By comparing multiple system options under real utility rates, load profile, and operational scenarios, LCCA in Trace software supports value-driven choices that align with budget constraints, sustainability goals, and building performance targets. Ultimately, it ensures HVAC investments are not just technically suitable but financially viable over time, reducing the risk of costly misjudgment.
Evaluate the impact of system requirements and performance issue associated with Trace 3D Plus. How might hardware limitation affect the usability of this software? Trace 3D Plus is a powerful energy modeling tool that integrates 3D modeling and BIM for precise analysis. However, it demands high system performance, and older or low spec computers may experience slowdown or crashes, especially with large simulations. This reduces productivity and complicate tasks like loading files or generating reports, posing challenges for smaller firms and students. As a result, hardware limitations can greatly impact the software's usability and effectiveness. So, this slide discusses the impact of system requirements and performance issue related to using 3D Plus software. The software demands high performance, hardware functions smoothly, particularly during large scale simulations. Low spec or older computers may experience lags or crashes, negatively affecting productivity and ease of use. These challenges are especially relevant for students or small firms with limited computing resources. Ultimately, hardware limitation can hinder the overall usability and effectiveness of Trace 3D Plus. So, next slide. So, what role does Trace software play in retrofitting and renovation projects? Discuss how it supports the evaluation of energy saving measure for existing buildings. Trace software is a key tool for evaluating energy efficiency improvements in building retrofits. It allows engineers to simulate a building's current energy use, identify inefficiencies, and test upgrade scenario, like better insulation or new HVAC system. The software includes life cycle cost analysis to assess financial viability, calculate ROI, and estimate carbon emission reductions. This helps stakeholders make informed, cost-effective, and suitable renovation decisions. So, these slides focuses on how Trace software contribute to retrofitting and renovation projects. It allows engineers to simulate buildings' current energy performance and explore improvements options. The software helps identify insufficiencies and test solutions, such as better insulation or updated HVAC system. It also includes financial tools like life cycle cost analysis and ROI estimation to support cost-effective decisions. This enables stakeholders to make informed, sustainable choices in building upgrade.
Discuss the future direction for the trace software in the field of energy modeling. What innovations could improve its functionality and industry relevance? Future development might include improved integration with other buildings' performance simulation tools, enhanced visualization capabilities, and the incorporation of machine learning algorithmic for more accurate and efficient simulations. The software could also benefit from improved users interface and more comprehensive support for various buildings types and climate zones. Increased focus on incorporating renewable energy sources into simulation would also enhance its relevance. To stay relevant in the rapidly advancing field of energy modeling, trace software must continue evolving towards smarter automation, border integration, and deeper environmental insight. By embracing cloud computing, AI, BIM compatibility, and real time data, Trace can remain a leading tool in optimizing building energy performance and supporting the future of sustainable design. So, in a further discussion, future improvement to Trace software should focus on user's interface or UI or UX, a more intuitive and visually appealing interface, perhaps incorporating interactive dashboards and 3D visualization will greatly enhance usability for wider range of users from architects to engineering to building owners. Next is advanced modeling capabilities. The software should able to handle more complex buildings systems including detailed HVAC or HVAC models, renewable energy sources such as solar, wind, and thermo, geothermal, and smart grid interaction. Improve algorithmic for simulation occupant behavior would also increase accuracy. Next is enhanced data analysis and reporting are more sophisticated data analysis tools including machine learning algorithms would also or allow for the identification of stable energy saving opportunity. Custom, customizable reports tailored to specific stakeholders such as investors, regulators would improve communication and decision making. Next is cloud based platform and collaboration tools. A cloud based platform will enable real time collaboration among multiple users regardless of location. version control, and secure data sharing features and would essential. Lastly is machine learning and AI integration. Incorporating machine learning could lead to more accurate energy predictions, and optimization of energy saving measures, and predictive maintenance capabilities. AI powered assistance futures and guide users to complex modeling tasks. In conclusion, this enhance would significantly improve Trace functionality and solidify its position as a leading energy modeling software.